When Maxwell proposed an additional term be added to Ampere's law to allow a changing electric field to induce a magnetic field, it had a combination of two constants, the permeability of free space times the permittivity of free space. We're going to spend just a little bit of time looking at what that combination is. So permeability free space times permittivity of free space. These are mu naught is 4 pi times 10 to the minus 7, and that is Tesla meter per ampere, and the permittivity of free space 8.85 times 10 to the minus 12, and that is Coulomb squared per Newton meter squared. So we multiply that out, keep a few decimal points here, 1.112 times 10 to the minus 17, and we have some god-awful units. So a Tesla is going to give us a Newton per meter per amp. I still have a meter per amp. And then from the permittivity, I've got Coulomb squared per Newton meter squared. Alright, so let's get rid of some of the things that cancel. I have a Newton over a Newton, meter over a meter. Alright, so let's look at that. 1.112 times 10 to the minus 17, and we have a Coulomb squared. I have an amp squared in the denominator, which is going to give us Coulomb squared second square in the numerator, and I still have this meter squared. So obviously the Coulomb squared over the Coulomb squared cancels out. So mu naught times epsilon naught has units of second squared over meter squared, which that is interesting. So let's reciprocate both sides. 1 over mu naught epsilon naught then is going to be 8.992 times 10 to the 16th meters squared per second squared. Which that might look familiar to you. If not, let me do one more line. Take a square root of both sides. So 1 over mu naught epsilon naught square root is going to be 2.999 times 10 to the 8th meters per second, which is the speed of light in a vacuum. So Maxwell's addition to Ampere's law is including a term for the rate of change of an electric field as part of the displacement current, and we have the speed of light squared in the equation as well. So that addition to Ampere's law from James Clerk Maxwell has the speed of light, and it's the speed of light in vacuum, and it is independent of the motion of the source of the changing electric field or the motion of anything involved in the problem. It's just the speed of light, the same for all observers.